If you sucked all of the moisture out of your brain and broke it down to its constituent nutritional content, what would it look like? Most of the weight of your dehydrated brain would come from fats, also known as lipids. In the remaining brain matter, you would find proteins and amino acids, traces of micronutrients, and glucose. The brain is, of course, more than just the sum of its nutritional parts, but each component does have a distinct impact on functioning, development, mood, and energy. So that post-lunch apathy or late-night alertness you might be feeling, well, that could simply be the effects of food on your brain. Of the fats in your brain, the superstars are omegas 3 and 6. These essential fatty acids, which have been linked to preventing degenerative brain conditions, must come from our diets. So eating omega-rich foods like nuts, seeds, and fatty fish is crucial to the creation and maintenance of cell membranes. And while omegas are good fats for your brain, long-term consumption of other fats, like trans and saturated fats, may compromise brain health. Meanwhile, proteins and amino acids, the building block nutrients of growth and development, manipulate how we feel and behave. Amino acids contain the precursors to neurotransmitters, the chemical messengers that carry signals between neurons, affecting things like mood, sleep, attentiveness, and weight. They're one of the reasons we might feel calm after eating a large plate of pasta, or more alert after a protein-rich meal. The complex combinations of compounds in food can stimulate brain cells to release mood-altering norepinephrine, dopamine, and serotonin. But getting to your brain cells is tricky, and amino acids have to compete for limited access. A diet with a range of foods helps maintain a balanced combination of brain messengers and keeps your mood from getting skewed in one direction or the other. Like the other organs in our bodies, our brains also benefit from a steady supply of micronutrients. Antioxidants in fruits and vegetables strengthen the brain to fight off free radicals that destroy brain cells, enabling your brain to work well for a longer period of time. And without powerful micronutrients like the vitamins B6, B12, and folic acid, our brains would be susceptible to brain disease and mental decline. Trace amounts of the minerals iron, copper, zinc, and sodium are also fundamental to brain health and early cognitive development. In order for the brain to efficiently transform and synthesize these valuable nutrients, it needs fuel, and lots of it. While the human brain only makes up about 2% of our body weight, it uses up to 20% of our energy resources. Most of this energy comes from carbohydrates that our body digests into glucose or blood sugar. The frontal lobes are so sensitive to drops in glucose, in fact, that a change in mental function is one of the primary signals of nutrient deficiency. Assuming that we are getting glucose regularly, how does the specific type of carbohydrates we eat affect our brains? Carbs come in 3 forms: starch, sugar, and fiber. While on most nutrition labels, they are all lumped into one total carb count, the ratio of the sugar and fiber subgroups to the whole amount affect how the body and brain respond. A high glycemic food, like white bread, causes a rapid release of glucose into the blood, and then comes the dip. Blood sugar shoots down, and with it, our attention span and mood. On the other hand, oats, grains, and legumes have slower glucose release, enabling a steadier level of attentiveness. For sustained brain power, opting for a varied diet of nutrient-rich foods is critical. When it comes to what you bite, chew, and swallow, your choices have a direct and long-lasting effect on the most powerful organ in your body. We hear about calories all the time. How many calories are in this cookie? How many are burned by 100 jumping jacks, or long-distance running, or fidgeting? But what is a calorie really? And how many of them do we actually need? Calories are a way of keeping track of the body's energy budget. A healthy balance occurs when we put in about as much energy as we lose. If we consistently put more energy into our bodies than we burn, the excess will gradually be stored as fat in our cells. and we'll gain weight. If we burn off more energy than we replenish, we'll lose weight. So we have to be able to measure the energy we consume and use, and we do so with a unit called the calorie. 1 calorie, the kind we measure in food, also called a large calorie, is defined as the amount of energy it would take to raise the temperature of 1 kilogram of water by 1 degree Celsius. Everything we consume has a calorie count, a measure of how much energy the item stores in its chemical bonds. The average pizza slice has 272 calories. There are about 78 in a piece of bread, and an apple has about 52. That energy is released during digestion and stored in other molecules that can be broken down to provide energy when the body needs it. It's used in 3 ways. About 10% enables digestion, about 20% fuels physical activity, and the biggest chunk, around 70%, supports the basic functions of our organs and tissues. That third usage corresponds to your basal metabolic rate, a number of calories you would need to survive if you weren't eating or moving around. Add in some physical activity and digestion, and you arrive at the official guidelines for how many calories the average person requires each day: 2,000 for women and 2,500 for men. Those estimates are based on factors like average weight, physical activity, and muscle mass. So does that mean everyone should shoot for around 2,000 calories? Not necessarily. If you're doing an energy-guzzling activity, like cycling the Tour de France, your body could use up to 9,000 calories per day. Pregnancy requires slightly more calories than usual. And elderly people typically have a slower metabolic rate. Energy is burned more gradually, so less is needed. Here's something else you should know before you start counting calories. The calorie counts on nutrition labels measure how much energy the food contains, not how much energy you can actually get out of it. Fibrous foods like celery and whole wheat take more energy to digest, so you'd actually wind up with less energy from a 100-calorie serving of celery than a 100-calorie serving of potato chips. Not to mention the fact that some foods offer nutrients like protein and vitamins, while others provide far less nutritional value. Eating too many of those foods could leave you overweight and malnourished. And even with the exact same food, different people might not get the same number of calories. Variations in things like enzyme levels, gut bacteria, and even intestine length means that every individual's ability to extract energy from food is a little different. So a calorie is a useful energy measure, but to work out exactly how many of them each of us requires, we need to factor in things like exercise, food type, and our body's ability to process energy. Good luck finding all of that on a nutrition label. Which of these has the least carbohydrates? This roll of bread, this bowl of rice, or this can of soda? It's a trick question. Although they may differ in fats, vitamins, and other nutritional content, when it comes to carbs, they're pretty much the same. So what exactly does that mean for your diet? First of all, carbohydrate is the nutritional category for sugars and molecules that your body breaks down to make sugars. Carbohydrates can be simple or complex, depending on their structure. This is a simple sugar, or monosaccharide. Glucose, fructose, and galactose are all simple sugars. Link 2 of them together, and you've got a disaccharide: lactose, maltose, or sucrose. Complex carbohydrates, on the other hand, have 3 or more simple sugars strung together. Complex carbohydrates with 3 to 10 linked sugars are oligosaccharides. Those with more than 10 are polysaccharides. During digestion, your body breaks down those complex carbohydrates into their monosaccharide building blocks, which your cells can use for energy. So when you eat any carbohydrate-rich food, the sugar level in your blood, normally about a teaspoon, goes up, but your digestive tract doesn't respond to all carbohydrates the same. Consider starch and fiber, both polysaccharides, both derived from plants, both composed of hundreds to thousands of monosaccharides joined together, but they're joined together differently, and that changes the effect they have on your body. In starches, which plants mostly store for energy in roots and seeds, glucose molecules are joined together by alpha linkages, most of which can be easily cleaved by enzymes in your digestive tract. But in fiber, the bonds between monosaccharide molecules are beta bonds, which your body can't break down. Fiber can also trap some starches, preventing them from being cleaved, resulting in something called resistant starch. So foods high in starch, like crackers and white bread, are digested easily, quickly releasing a whole bunch of glucose into your blood, exactly what would happen if you drank something high in glucose, like soda. These foods have a high glycemic index, the amount that a particular food raises the sugar level in your blood. Soda and white bread have a similar glycemic index because they have a similar effect on your blood sugar. But when you eat foods high in fiber, like vegetables, fruits, and whole grains, those indigestible beta bonds slow the release of glucose into the blood. Those foods have a lower glycemic index, and foods like eggs, cheese, and meats have the lowest glycemic index. When sugar moves from the digestive tract to the bloodstream, your body kicks into action to transfer it into your tissues, where it can be processed and used for energy. Insulin, a hormone synthesized in the pancreas, is one of the body's main tools for sugar management. When you eat and your blood sugar rises, insulin is secreted into the blood. It prompts your muscle and fat cells to let glucose in and jumpstarts the conversion of sugar to energy. The degree to which a unit of insulin lowers the blood sugar helps us understand something called insulin sensitivity. The more a given unit of insulin lowers blood sugar, the more sensitive you are to insulin. If insulin sensitivity goes down, that's known as insulin resistance. The pancreas still sends out insulin, but cells, especially muscle cells, are less and less responsive to it. So blood sugar fails to decrease, and blood insulin continues to rise. Chronically consuming a lot of carbohydrates may lead to insulin resistance, and many scientists believe that insulin resistance leads to a serious condition called metabolic syndrome. That involves a constellation of symptoms, including high blood sugar, increased waist circumference, and high blood pressure. It increases the risk of developing conditions like cardiovascular disease and type 2 diabetes. And its prevalence is rapidly increasing all over the world. As much as 32% of the population in the US has metabolic syndrome. So let's get back to your diet. Whether your food tastes sweet or not, sugar is sugar, and too many carbs can be a problem. So maybe you'll want to take a pass on that pasta, sushi roll, pita burrito, donut burger sandwich.
If you go to the store in search of milk, there are a dizzying number of products to choose from. There's dairy milk, but also plant-based products. To turn a plant into something resembling milk, it must be either soaked, drained, rinsed, and milled into a thick paste, or dried and milled into flour. The plant paste or flour is then fortified with vitamins and minerals, flavored, and diluted with water. The result is a barrage of options that share many of the qualities of animal milk. So which milk is actually best for you? Let's dive into some of the most popular milks: dairy, almond, soy, or oat. A 250 milliliter glass of cow's milk contains 8 grams of protein, 12 grams of carbohydrates, and 2 to 8 grams of fat, depending on if it's skim, reduced fat, or whole. That's approximately 15% the daily protein an average adult needs, roughly 10% the carbohydrates, and 2 to 15% the fat. Most plant-based milks have less carbohydrates than dairy milk. They also have less fat, but more of what's often called good fats. Meanwhile, the healthy nutrients vitamin D and calcium found in dairy milk don't occur naturally in most plant-based milks. Looking more closely at our plant-based milks, both almond and oat are low in protein compared to dairy. But while almond milk has the least nutrients of the 4, oat milk is full of beta-glucans, a healthy type of fiber. It also has a lot of carbohydrates compared to other plant milks, sometimes as much as dairy milk. Soy milk, meanwhile, has as much protein as cow's milk and is also a great source of potassium. Soybeans contain isoflavone, which people used to think might trigger hormonal imbalances by mimicking the function of estrogen. But ultimately, soy milk contains very small amounts of isoflavones, which have a much weaker effect on our bodies than estrogen. Depending on individual circumstances, one of these milks may be the clear winner. If you're lactose intolerant, then the plant-based milks pull ahead, while if you're allergic to nuts, almond milk is out. For people who don't have access to a wide and varied diet, dairy milk can be the most efficient way to get these nutrients. But all else being equal, any one of these 4 milks is nutritious enough to be part of a balanced diet. That's why for many people, the milk that's best for you is actually the milk that's best for the planet. So which uses the fewest resources and produces the least pollution? It takes almost 4 square kilometers to produce just 1 glass of cow's milk, land use that drives deforestation and habitat destruction. Most of that is land the cows live on, and some is used to grow their feed. Many cows eat soybeans and oats. It takes much less land to grow the oats or soybeans for milk than it does to feed a dairy cow, only about a quarter square kilometer per glass. Almond milk has similar land use, but where that land is also matters. Soybean farms are a major driver of deforestation, while oat and almond farms aren't. Making milk uses water every step of the way, but it's the farming stage where big differences emerge. Dairy milk uses the most water, about 120 liters per glass, mostly to water cows and grow their food. Almonds take second place, at more than 70 liters of water per glass. Most of that water is used to grow almond trees, which take years of watering before they start producing almonds. The trees must be watered consistently or they die, while many other crops can be left fallow and still produce later. All told, soy and oats require less water to grow, only about 5 to 10 liters per glass of milk. Milk production generates some greenhouse gas emissions, about 0.1 to 0.2 kilograms per glass for the plant-based milks. But for dairy milk, the cows themselves also produce emissions by burping and farting out large quantities of the gas methane. Overall, each glass of dairy milk contributes over half a kilogram of greenhouse gas emissions. So while depending on your dietary needs, any one of these milks may be a good fit, in terms of the health of our planet, there's a strong case for choosing plant-based milks, particularly oat or soy milk. So how exactly does the food you eat affect the most powerful organ in your body?